So this sounds kind of arbitrary. That e power ai, if I put a as a slider, so that this is your angle, and that it goes around the circle like this. It sounds arbitrary, right? But what is this thing? A e to the ai, right? First, you have to understand what does it mean to have e power x. This is called the exponential function, right? It is this. You see, it's exactly the same thing. If I put exponential, you see it's exactly the same thing. But how is it defined? It is actually just an infinite sum. It's, well, look what happens. If I do 1 plus x plus x power 2 over 2 plus x power 3 over 2 times 3. By the way, you can think of 2 as being 1 times 2, and this is can be 1 times 2 times 3. Let's also put time here. And what happens if we add one more? Well, you see already that here it kind of fits the curve, right? Kind of. Get kind of fix the curve. Let's add another one. Let's add another one. Let's do plus x power 4 divided by 1 times 2 times 3 times 4. Damn, it fits even more. You know what happens here? So how do we write this sum so that I can increase the number without having to type everything by hand? Well, we can type it like this. Let's put a p here so I can change later, and then it's basically x power p divide power n, sorry, divided by n factorial. N factorial means 1 times 2 times 3 times 4 until you get to n. And it proposed to put the sliders, we get it. So here we went to 0, 1, 2, 3, 4. What happens here if I put 4? You see that it ends up fitting that blue curve, right? So you can see it's the same thing. So what happens if I increase this value to, I don't know, let's say up to 1000. Let's zoom a little. So remember, the purple is our exponential function, and our green one is our, let's remove the blue one, and the green the green one is our sum. So if I increase p, you see it fits more and more the curve. You can zoom even more. As p increase, it fits more and more the curve. So when you do this to infinity, that's the definition of the exponential function. Now, what happens if instead of real numbers, because here they are just real numbers, I put complex numbers? So let's go back to our function, our sum here, so we can understand a bit better. First, what happens? Let's put back cosine of a times plus sine of ai, and let's zoom back to whatever, and let's put a slider here. Right, let's zoom even more. Right, you see this thing that goes around the circle. okay, what if we take this formula and instead of x, we put the complex number like this, where we will just change we will add I on it, basically. So we will do that thing. Oh shit. Well, let's change it here, it's better. So if I do this and I put an I and I put thing like this, you see the value here? And they strangely match those ones really closely, right? Yeah, it's crazy. And as I move around, this this black point follows the green one. Damn. You see that at some point it becomes undefined. Where? It doesn't? Huh, interesting. Because the n when p becomes big, it blows up to infinity. The the computer will try to do exponential of 1000, and computing this number is like it's a huge number. It's like more particle than it's more than the number of particle in the universe. Basically, the computer is like dying, but mathematically it's well defined, and you see here, if I don't put a big value, it's already really close. But it is following and following a circle, and then you can actually mm, you can actually come up to this function with you see where you have two sums. You have sinus of I and cos of A. This is basically this function. Yeah, so that one on top where you have I, but I always cancels out because basically yeah, you just gather the i's together and the real part and the imaginary parts, and it splits in two. It splits cleanly into a sine and then a cosine function. So that means then that you have like an infinite sum that converge to cosine and another infinite sum that converge to sine, but with on another dimension, basically the I dimension, what we call complex number. And this is basically it.